Hey guys, it's me, Mr. Arias. Hey, I'm gonna be recording some of the lessons for the next couple of days because I won't be in class. So you guys will have access to them. They'll be on Canvas, so you guys can see them as many times as you guys like. Okay? So let's go ahead and let's get started. So this is going to be Monday's lesson, all right? When you guys come back from spring break, and this is just a review over Module 11 out of your textbook. Okay, so let's go ahead and let's get started. So on number 1, it says find the domain of the quadratic function, its inverse, graph it, and prove it's an inverse through composition. Okay, so here's our first function right here. It's a quadratic equation. All right, it's x squared minus 4. And so it's going to look like this. It's going to have a y-intercept of -4. All right, and here are a few points that you can use to graph. All right, so there it is. There's a quadratic equation. All right, so let's start with the very first part. It says right here, it says find the restricted domain, okay? And it says hint, it's the same as the range of the inverse, right? Actually, you know what? I will come back to this afterwards. First, let's do this. Let's find the inverse. Now, if you remember, in order to find the inverse, the very first step is we need to switch the x's and y's. So you would get x equals y squared minus 4. And then you solve for y. So you would do that by adding 4 to both sides. Then you get x plus 4 equals y squared. And then finally, you take the square root of both sides. So you get y equals the square root of x plus 4. And so that's your inverse. And please don't forget that whenever you have the inverse, what needs to go right here in the top right corner of the y value, the y variable? A -1. And that basically tells you it's the inverse. And so there it is. Okay? Now you can always graph this by hand, making a table, or just using your calculator. Now, if you remember, because we've gone over these functions right here, the square root function, this plus 4 shifts the graph to the left 4 points. So if you start at the center, it would shift it left 4, so 1, 2, 3, 4. And if you want to use your calculator, feel free to use it and go to the table and look up some points. If you don't, then you can always just make a quick little XY table. So for example, I'm going to plug in -3, and if I plug -3 in here, I get -3 plus 4, which is the square root of 1, which is 1. And so that gives me another point right here. And of course, if you plug in 0, you would get 0 plus 4, which is the square root of 4, which is 2. And so that gives you this point right here. And so there is the inverse. Okay, there's the inverse. Now, the next part right here, it says prove through composition. Now, remember, through composition, that means that you're going to plug in the inverse into the original function, right? So you're going to plug into the original function the inverse, which is like this, right? And so you're going to take this part, and you're going to plug it in here for x squared. So when you plug it in, you're going to get the square root of x plus 4 squared minus 4. And so when you do substitute it, you'll see that the square and the square root cancel, 4 and -4 cancel, and you're left with x. And remember that if you're left with x, then that means that this, in fact, is the inverse. It is correct. Okay? Now, the last thing, which I kind of skipped over at the beginning, is the restricted domain. Okay, so you remember that we talked about that the inverse and the original function have a special relationship, that they reflect across this line right here, y equals x. They reflect, right? Now, if you were to take this original function right here in what I believe is blue or purple, and if you were to reflect it, you should get a function that looks like this. You should get this right here. Right, there's a problem though. When you get this top and this bottom branch and you do the vertical line test, what happens is that it fails because it intersects at 2 points, which would mean that the inverse is not a function, okay? And because of that, here, give me a second. And because of that, what we do is we restrict the domain. And I gave you guys a hint. It's the same thing as the range of the inverse. So in order to get only half of this right here, the top branch, you're only going to use the right-hand side right here of the original function, which is x is greater than or equal to 0, or you can say 0 to infinity. Now, if you have trouble with that, if you remember that the range of the inverse of that graph, and here, let me remove some of this stuff. Here. Okay, if you remember, the range of the inverse, which is right here and goes upward, starts from 0 and goes upward to infinity, the range of the inverse, which is this function right here, okay, is from 0 to infinity. Well, if you remember from when we first started with inverses, what do? We always switch the x's and the y's, right? Well, the range represents the y values and the domain represents the x values. So if you want the domain of the original function, if you want this domain of this original function right here, that right there is going to be the same thing as the range of the inverse. It's the same thing. So what would the restricted domain be right here? Well, that's going to be the same thing as the range of the inverse, which is right over here, which is 0 to infinity, which is the same thing that we just got a moment ago. Okay? So if it helps you, just remember that the restricted domain of the original function is exactly the same thing as the range of the inverse. Okay, that just makes it easier. Okay. All right, so let's go on to the next one. Now I'm going to skip number 2 because it's very similar to number 1, so you guys can practice that on your own. I'll leave number 1 here in the video so you guys can use that as a reference. All right, so let's go to number 3. So it says a function d of t equals 12.5 t squared gives a height y in meters of, and that should really be dt. This should really be d. Okay, that an object dropped from a height will fall in t seconds. Find the inverse. So we need to find the inverse. So the original function is 12.5 t squared. Okay, so that's the original. Now remember that when we talked about finding the inverse in a word problem, you really only need to just find or solve for this other letter right here. That's really all you need to do. So how do we solve for t? Well, you divide both sides by 12.5 first. And then you get d equals, d over 12.5 equals t squared. And then finally, what do? You take the square root. And so there it is. There's the inverse. So t is equal to the square root of d over 12.5. And then it says, find the time it takes to fall 60 meters. So how long would it take? We're going to take the square root of 60 over 12.5. And then if you plug that in your calculator, let's see, what do we get? All right, so I got 2.19, and I'm going to round to 1 seconds. All right. Okay, so now let's go on to another example. All right, so on number 4, and I believe also we take a look right here at number 5, it says find the inverse of the function, graph it, and what is the domain and range of the inverse? Okay, so the only, if you take a look right here at, where are we, 4 and 5, if you pay close attention, these are actually, if you look right here, these are actually cube functions, okay, the cubic functions. So be very, very careful. So let's go ahead and let's get started. So this equation is y equals a negative 2x cubed. And so first of all, if we switch the values, we get this. And of course, solve for y. So we would divide by negative 2 first. And we get x over negative 2 equals y cubed. And if you recall, how do we get rid of a to the power of 3? Remember, it's not the square root, but it is the cube root. And you put the 3 right here. And remember, that was called an index. That was called the index. All right? And so the inverse, remember, needs a little negative 1 right here. you get the cube root of x over negative 2. And so there it is. There's a function. Okay. Now, if you recall from last week, before spring break, every cube root function, well, the parent function starts off like this, right? And then 2 over, goes over 2 up 8, 1, 2, 3, 4, 5, 6, 7, 8. This is just the parent function. I'm just graphing the parent function. You don't need to, but just to show you guys. That's the parent function, right? Now, the only difference is this one has a is equal to negative 2. So remember that when that's negative 2, that's a vertical stretch and it's a reflection. So what it's going to do is it's going to reflect it, and instead of going up 1 right here at this point, it's going to go downward. So if we flip these values, we get this. This is what the function looks like now. Okay? It's the one in blue. All right? Now, if you also remember that for every cube function, you remember that the domain and range are always going to be all real numbers. Now, remember that when we also talked about whenever you find the inverse, that the domain and the range switch. Remember that whenever you find this inverse, the domain and range switch. Well, if both of them are all real numbers, then that means it's still going to be all real numbers. So this is just going to stay the same. So that should just be really easy right there. And then, of course, the inverse is right there. Okay. Now, I know it doesn't ask you to do it, but you should always practice. Proving it through composition. Oh, by the way, and I apologize, I forgot. I did not actually graph the inverse. So to graph this inverse, you see these points, right? You can, like I said, you can always use your calculator. Okay, there's nothing wrong with it. Or if you just like doing stuff by hand, you can always do stuff by hand. This point is 1 comma negative 2, and this one right here is negative 1 comma 2. And if you remember, when you find the inverse, you just switch x's and y's. So that means that the other point, when I switch 1, negative 2, should be negative 2, 1. And when you switch negative 1, 2, should be 2, negative 1. And so this is what... So this one right here is the inverse. That one right there is the inverse. Okay? And I'll erase this. I'm erasing the parent function. I don't want to confuse anybody. So there you go. So the one in black right there, that's the inverse, and the one in blue, that's the original function. And like I said, in order just to practice to find, proving through composition, you can always plug that in to the original function. So you take the original function f, and you're going to plug in the inverse, f of negative 1, which is, if we take a look at the original function, is negative 2x cubed, so this is negative 2. And what's the inverse? It's the cube root of x over negative 2. And so the cube root and the power of 3 cancel, and negative 2 divided by negative 2 cancel, and you're left with x, which proves that, yes, this is a inverse. Okay. All right, let's go on to our next example over here. All right, so on numbers, what is this? 6, 7, and 8. Okay. They basically both work the same way. You're going to find out what the transformations are, find out what the domain and range are. Now, just keep an open eye. These are not cube functions. If you look right here, these are just square root functions. So just keep that in mind. They're not the same thing. All right, so let's see. Which one can we do? Well, it doesn't really matter. They're both exactly the same. All right, so number 6 says find the domain and range of g of x and graph it. Okay, so if you recall, these values right here, this minus 3 and this plus 4, they move the graph left, right, up, and down. The minus 3 right there is going to move the graph to the right 3 units. And the plus 4 will move it up 4 units. Okay? Then the next thing is the negative 2 right here. All right, because it's negative, that's the value of a, first of all. Okay, because it's negative, that's a reflection. And then second of all, because the absolute value of negative 2 is 2, and that's bigger than 1, then that's going to be a vertical stretch. All right, so now we can go ahead and use our transformations. So it says right 3 up 4. So if I start from the center and I go right 3 up 4, that'll be 1. By the way, keep in mind, these graphs go by 2s. I don't know why, I apologize. I don't know why some of them go by 2s and some of them go by 1s, okay? So let's see, that's right 3, up 4, so that's 1, 2, 3, and then up 4. So there's our first point, okay? Now it says that we have a vertical stretch and a reflection. Now we can always just plug in some points and find out what the other ones are. Or like I said, feel free to use your calculator if you want to. There's nothing wrong with it. All right, and so let's see. I'm going to pick 4. So if I plug in 4 into that function, I would get the square root of 4 minus 3 plus 4. And the square root of, well, 4 minus 3 is going to be 1. So negative 2 times the square root of 1 plus 4. Square root of 1 is 1, and 1 times negative 2 is negative 2, plus 4 is 2. So we get 4 comma 2. And if we connect our dots, this is what the graph will look like. Remember that square root functions are not like cubic functions where the domain and range is always all real numbers. All right, so now let's go back here. Let's erase this. All right, so what's the domain? Now remember, the domain is all your x values. All right, it's all the x values. So if you come over here to your graph, all right, and if you want to, let's see, we can draw a vertical line right here. Okay, so it starts at 3 and it keeps going this way forever and ever into infinity. So that would give us a domain of 3 to infinity. And remember, you put a parentheses around infinity because it's not a real number, okay? You never actually touch it. And 3, you put a box because it actually is included. Your graph actually does touch 3, okay? And if you want to find another way to write it, you can always say x is just greater than or equal to 3. Now the range is your y values. Now you notice that this graph over here keeps going downward forever and ever. It keeps going downward. It never ever stops. So what that tells us is that this graph is going to keep going downward slowly, little by little, to negative infinity. And what's the largest y value? The largest y value it touches is 4. So it's from negative infinity to 4. All right, and so then we could say y is less than or equal to 4. All right, and so there it is. And like I said, okay, number 8 is going to work almost identically the same. All right. All right, let's see what else we got here. Okay, so if we go down here, let's see, there's number 9. All right, here, let's take a look at number 9 right here. Okay, these are the ones where you have the graph and you have to work backwards. Okay, so first of all, notice that this is a cubic function. All right, and it says describe the transformations, the domain and range. All right, so here, let's try to do the easiest parts first. All right, so the easiest part. So the domain and range of a cubic function, hopefully by now we know, is all real numbers. Or you just want to write it a different way, you can just say it's negative infinity to infinity. Okay, either or, they're both the same. Now, as far as the transformations, okay, remember what we talked about? You need to find the center of this graph. The center of the graph is, if you were to draw lines that go up and down and across, it would split this graph right down the middle on both sides. So you notice that we get the same curve on this side as we do right here on this side. That means that this point right here is going to be our center. That's our center right there. And so, all right, so what's the coordinate of our center? And again, remember, this graph is going by 2's. So that's actually a center of -2, -2. So that's our center. So that means that this graph was translated left, here we go, left 2 and down 2. Okay, so left 2, down 2. All right, and now we need to find out the rest of the parts of this equation. So let's go ahead and let's start. So this is a, the cube root of x. Now, what's going to go in place of minus h underneath the cube root? That would be x. And please remember, that's going to be x plus 2, because remember, you always do the opposite. You always have to flip the x value. And then outside our k value is going to be minus 2, right? So now the very, very last part is we need to find out what this a value is. So to find out the a value, pick another point on your graph. It doesn't really matter which one you pick, you're still going to get exactly the same answer. So I can pick this point right here, which looks like -1, 1, or I can pick this one, which looks like 6, 4. Like I said, either or both will still give you the same exact answer. So I guess I'm going to pick, because it's always easier to deal with smaller numbers. That looks like negative 1, 1. All right, I want to pick that one. So I want to substitute that in here. So we get a, the cube root of negative 1 plus 2 minus 2. And so if we start solving, let's see, let's move this 2 over here. We get 3 equals a, the cube root of negative 1 plus 2 is 1. And the cube root of 1 is 1. By the way, if you have trouble with that, you can always plug that into your calculator. The cube root of 1 is going to be 1. So you're left with a is equal to 3. And so here is the equation. G of x is equal to 3, the cube root of x plus 2 minus 2. And there it is. Oh, and by the way, since a is equal to 3, that's going to give us a vertical stretch. Okay. All right, let's go ahead and let's take a look and see what else we got here. All right, so on this page right here, we have a couple of questions where they give you the transformations and you have to write it all out. All right, here, let's try 11. Okay, so it says the parent function y equals the square root of x is horizontally compressed by a factor of 1/3. Okay, so if we fill that in, now remember that anything that has to do with horizontal transformations, that goes underneath the root, goes underneath here. So I'm going to put that 1/3 right here. And so now let's look at the other part. It says it goes 3 to the right. So that's going to be x plus 3 or minus 3. Okay, it's going to be minus 3. So again, please try to remember, you always do the opposite. So that's going to be minus 3, and then it says, and 12 up. So let's do plus 12 goes out here. All right, what's the new equation? There you go. That's it. Okay. By the way, if you're having trouble, okay, just remember, b right here, b is actually the denominator. Okay, so that's actually the value of b, which is b is equal to 3, which then is going to give us, that's a horizontal, because it's greater than 1, that's actually a horizontal, because 3 is bigger than 1, that gives us a horizontal stretch. What do you know? There's a typo here. Yeah, it's a horizontal stretch, should be 1/3. Oh, okay, my apologies, my apologies. So it says horizontally compressed by a factor of 1/3. Okay, so right here in the denominator, my apologies, you guys. Okay, so this should actually just be 1/3. Because if it's 1/3, that means b would be 1/3, and if b is b or a, if either of them are ever between 0 and 1, that's a horizontal compression. All right, and that would satisfy the word problem. Okay, so my apologies, you guys. So it's a horizontal compression. So just remember, if it's ever between 0 and 1, it's a compression. If it's bigger than 1, it's a stretch. Okay. All right, so let's see what else we have here. All right, so on number 12, and let's see what else we have. Oh, that's the test review. All right, so on the very last one, number 12, it says that you have to find the transformations, domain, and range, and this is a cube root function. Now, let's just double check. I'm pretty sure we kind of may have already done this. I'm not really going to go over number 12 because 12 is very similar to what we've already kind of already done. Just remember that this little 3 right here tells you it's a cube root function. So it's going to look something like this, right? And remember, we already talked about how the domain and range of what the domain and range of all cube root functions are. All the transformations still work almost identically the same as all the other ones, okay? Like I said, you can plug in certain values to find out what it is, find other points, or if you want to, you can always use your calculator. Okay. Now this right here, this is Monday's lesson. So this is a review over Module 11. All right. Whatever we didn't cover would be for homework and you would turn in the following day. Now, if you want to stop and review and look over the video, okay, you can stop and then just go backwards right now. Or if you want to, I'm going to go ahead and also get started on the test review. So if for those of you guys that are watching and you just want to go ahead and also maybe just get ahead or something, here's the test review. I'm going to do some of the test review also on this same lesson. Okay, so like I said, it's for those of you guys that want to get ahead, here it is. And if not, you can always stop and then just look at this tomorrow. Okay, so here we go. Let's go ahead and let's get started on the test review. All right, so on the test review, so number one, okay, it says restricted domain of the quadratic function and find its inverse, confirm the inverse relationship using composition, graph the function and its inverse. Okay, so like I said in the previous lesson, all right, so right here where it says a quadratic restricted domain, I'm going to come back to this later because remember I said that the domain of the original function, this is going to be the same as the range of the inverse. So to be honest with you, I can actually just skip this and then just come back to this at the end once I find the range of the inverse and then just copy it right here. Okay, so let's go ahead and skip that part. So the inverse. So let's go ahead and let's get started. This is y equals 3x squared. And again, first, whenever you find the inverse, what do you do with the x and the y's? You're going to switch these, and so you get x equals 3y squared. And so you divide by 3. And so you're going to get y squared equals x over 3. And then finally, what do you do to get rid of the square? You take the square root. So you get, I'm kind of running out of space here, y equals the square root of x over 3. And remember, what else needs to go right up above to the right of this y to represent it's an inverse? You need a -1. And so that's your inverse equation, right? And so to prove through composition, all right, I'm going to erase some of this over here and do it over here. All right, so to prove through composition, I'm going to plug that equation into the original one. So here's the original f, and inside of it, I'm going to plug in the inverse. So 3 parentheses. So what's the inverse? I'm going to plug this right here. So that's going to be the square root of x over 3. And so what happens when we substitute in this square root and this square? They cancel. 3 divided by 3 cancels, and you're left with nothing but x, which in fact proves that this answer that we got before, the inverse, is actually correct. So there it is. Now, it says, all right, now let's do the other parts. Now, this is a square root function that's x over 3. Now, it's still going to start at 0, 0. So if I make a little table right here off to the side for the inverse, if I plug in 0, I still get 0. If I plug in 3, let's see what we get. Square root of 3 over 3 is going to give us 1. So here's 0, 0, and at 3 I get 1, and so there's a graph. There's the inverse. Okay. Now, it says, what's the inverse restricted domain? So the inverse, that should really just say what the domain of the inverse is. So if you look over here at your graph, your domain of the inverse is just 0 to infinity. Starts at 0, goes infinity. All right. And remember I said, now let's go back to the beginning one. It said the quadratic restricted domain. Remember we said this is the same as the range of the inverse. Okay. Range of the inverse right here. Okay. So what's the range? If you look right here, what's the smallest y value? The smallest y value is 0, and this graph steadily goes up and up until it gets to infinity. So that's from 0 to infinity. All right, and there you go. Okay. All right, now let's go ahead and... All right, let's go on. All right, so let's go to, let's see, what is this? All right, number 3, it says the function a equals pi r squared gives the area of a circular object with respect to r. Find the radius required for the area. So find the radius required for the area, then estimate the radius of a circular object that has an area of 75 square centimeters. So first we have to find the inverse. So again, like we talked about finding the inverse, you have to solve for the other variable. You don't need to switch anything, you just solve for the other variable. So if I want to solve for the letter r right here, all I'm going to do is I'm going to divide by pi first, and then once I divide by pi, I'm going to take the square root to get rid of that square right there. And so there's my inverse, and there it is. Now it says, what's the radius of an object that has an area of 75? So the radius, all you have to do is just substitute in 75 over pi. All right, and let's see what happens when we plug that into our calculator. By the way, it would be good if you guys went ahead and also went practice and try doing this as I'm doing it right now. So this is what I got. I got the radius is 4.886, and then it's centimeters. Okay, and there you go. All right, so let's go on to the next one. So here we have number 4. It says find the inverse of the cubic function and confirm the inverse using composition. Now this is very similar to what we've done before. So let's go ahead and let's start. So the inverse. So here's our equation. So same as before, let's go ahead and just switch these letters. And let's solve for y. So we get x minus 5 equals y cubed. And then again, how do you get rid of this y to the power of 3? Remember, it's not necessarily the square root, it's the cube root that's going to do that. So the cube root is going to take care of that power to 3. So that's y, the inverse of the cube root of x minus 5. And so there's your inverse. And then it says prove through composition. Well, if you plug this in, the cube root of x minus 5 to the power of 3 plus 5. So I'm plugging it in. And so the cube root and to the power of 3 cancel out, and you're left with this, x minus 5 plus 5. And these cancel, and so you're left with x. And check. That's good to go. So let's see what else we got here. Okay, it says graph the function and the inverse. All right. So the original one, x cubed plus 5, is going to have a y-intercept of 5. 1, 2, 3, 4, 5. So here it is. All right. And like I said, if you want to use a table, I know some of you guys don't like calculators, and some of you guys do. So whichever is better for you, whichever one it is you like. If you want to use a calculator, and by all means, just plug it into a calculator and go to your table. If you don't want to, then you could just make a table and just plug in some points. So for example, 0, 5 is 1. If I plug in 1 in there, 1 cubed is 1 plus 5 is 6. And so here's this point. If I plug in -1, -1 to the power of 3, by the way, be careful, -1 to the power of 3 is still -1, and so you get 4. There we go, and if we connect our points, there it is. So there's the inverse. Oh, my apologies, you guys. Okay, I was actually graphing, yes, I was graphing the original one. My apologies. All right, so there it is. So here's the original function. There's the original one. Now the inverse. Where's the inverse? Okay, so the inverse right here has a cube root of x minus 5, so that's going to shift it to the right 5 units. So that's going to be 1, 2, 3, 4, 5. All right, and if we change the dots and the points, okay, we get this. By the way, just in case, you can always check by also just do a really quick check by drawing the line y equals x. If you draw the line y equals x, you should get the same image on both sides. You should get the mirror image, which of course, if you take a look right here, we do. Okay? And so there it is. There's both the original function and the inverse. Also, by the way, make sure that you're always plotting at least 3 points. Don't just draw some crazy line on there without even looking up some points. All right? Okay, so let's see what else we got here. All right, so The next one is very, very similar, so I'm going to go ahead and skip that. Here, let's see what else we got here. All right, use the description to give the square root function with the given transformations. All right, so here we have number 6 and number 7. You're given the square root function and you're given transformations. All right. Now let's go ahead and let's see. Let's do. All right, number 6 says the graph is translated 3 units. 3 units to the left, so that's going to be x. So if that says 3 units to the left, that's minus 3, but will really be plus 3. Then it says it's translated vertically 7 units up, so it's going to be plus 7. And then it says it's going to be stretched horizontally, so stretched horizontally by a factor of 5. So if it says stretched horizontally, that means b is equal to 5. Because remember, if b or a are both bigger than 1, that's a stretch. So that means that inside of this function, we're going to have the square root, and we're going to have 1 over 5. Okay? And then finally it says reflected over the y-axis. So it says reflected over the y-axis. So since it's reflected over the y-axis, the negative goes inside of that root. And there you go. Okay. All right, so now let's go on to the next one. So like I said, I'm going to kind of skip number 7. It's very similar. All right, now number 8 and 9 says graph each square root function, state the domain and range. Okay, all right, let's go ahead. Let's do it. All right, I'm going to do number 9. So on number 9, first, do we have to state transformations? Blah, 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 blah. No. Okay, so, but I'm going to go ahead and just do it anyways. All right, just so you can get practice. All right, so this plus 5 right here, that's going to shift the graph left 5 units. And the plus 3 on the outside moves it up 3. And you see this 1/3 right here? Okay. So remember, b is what's in the denominator. Since b is equal to 3, that's a horizontal stretch. Also, by the way, I may have mentioned this to a few classes. All right. I don't know if this will help you, but just in case, some people's minds works differently, so maybe this may help you. If 1/3 was actually outside, so let's just say the 1/3 was here, right? The 1/3 was right there. Then that would be A. And if A was a 1/3, that would be a vertical compression. Now, why am I doing this? Well, because if it helps some of you guys, just in case, if you want to know FYI, a vertical compression is, guess what, exactly the same thing as a horizontal stretch. Basically, they're just opposites. So a vertical compression is the same thing as a horizontal stretch. And if you're wondering, yes, a vertical compression is the same exact thing as a horizontal stretch. So you can think of the number underneath the root as the letter A if it helps you. You can do that if you want to. Now, like I said, if you don't want to, that's fine. Then just remember the bottom number is B, and if that number is bigger than 1, it's a stretch. And if it's between 0 and 1, it's a compression. Okay? And so let's go ahead and let's graph this. So it's left 5 up 3, so 1, 2, 3, 4, 5. 1, 2, 3, so here's our point right here. Okay, and so we have a 1/3. That's just going to mess with our points. So instead of trying to do this by hand, I'm going to go to my calculator. And let's see what we can find. All right, so I went ahead and plugged in the equation to our calculator, and what I got was 7, 5. Yeah, 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That's kind of far away. Let's see if I can find something closer. I got negative 2, 4. So 1, 2, 3, 4. All right, and there it is. Okay, so what's the domain of this graph? Well, okay, again, so what is the smallest x value? Or which one is the farthest to the left, which is 1, 2, 3, 4, 5. So it's negative 5, and you notice this graph keeps going in this direction to infinity. So it's negative 5 to infinity. So there it is. And then the range are your y values. So let's go ahead and let's check that one now. So your range right here, the smallest y value is 1, 2, 3. So the smallest y value is 3, and it's making its way up steadily, little by little by little, until it gets to infinity. So it's 3 to infinity, and there it is. Okay. All right, let's see what else we got here. Now, number 10 is going to be very, very similar to what we just did. Just know that if there's a negative, like there is right here underneath the square root, okay, that's going to be a reflection, but that's going to be a reflection across the y-axis. All right, so let's go ahead and let's try something else. So number 11, it says circle all the items that apply to the following equation. So the starting point, which is going to come from this, that's right here, that's your starting point, is negative 8, negative 9. All right, what does it have? A vertical, horizontal, stretch, or compression? Well, first of all, this value is outside the square root, so that's going to be vertical something. Now, since it's 1/3, and that's between 0 and 1, that's going to be a compression. So that's a vertical compression. And there is no negative, so there's no reflection. Now, the horizontal translation is going to be left 8, and what is that? Vertical translation is down 9. Now, let's go on to our cube root functions. All right, so here we go. Here's some of our cube root functions. So number 12 says graph each cubic function. So the transformations, first of all, I'm going to go through that because we just need to practice, all right? Practice makes perfect. So a right here is negative 3. That's the value of a, and it's negative. So it'll give you a reflection. It's also the absolute value of negative 3, which is 3, is bigger than 1, so that's a vertical stretch. And the plus 2 in the inside, that moves it to the left 2 and down 5. So I'm going to go ahead and get started on that. So left 2 and down 5. So there it is. And let's see. Now this time, actually, you know what? We can make a quick little XY table and find some other points. So I went left 2. Let's do negative 1. If I plug a negative 1 in there, I would get the negative 3 cube root of negative 1 plus 2 is 1 minus 5, and the cube root of 1 is 1. So negative 3 minus 5 would give us a negative 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8. That would be here. And I hope you realize that the cubic function is symmetric, so I can actually just do the same exact thing on the opposite side of the center. So if I went down 3 over 1, I can do the same thing. 1, 2, 3, 1, 2, 3 over 1, and then connect my graph. So there it is. And so there's my graph. Now let's see. Here, let's do, you know what, I'll let you guys do 13 because I think we've practiced that enough. So go ahead and try doing 13 on your own, and I'll leave you guys to do 15 as well. All right, so let's go back right here to, let's do 16. So right here on 16, so this is going to have, because the negative's underneath the root, that's going to be a reflection across the y-axis. Remember that if it's outside the cube root, it's a reflection across the x-axis. So if it's outside the cube root, it's a reflection across the x-axis. So we have that transformation. It's left 2 and up 6. So let's see, left 2, up 6, 1, 2, 3, 4, 5, 6. There's 1 point. Now let's see, I'm going to substitute a value in here. Let's see what we get. Let's see if I plug in -1. It's always easiest, by the way, to plug in points that are very, very, very close to the center. So if I plug in -1, I want to get the cube root of a negative, and this will be -1 plus 2 plus 6. And so the cube root, -1 plus 2 is 1, and then it's going to change into a negative. And remember we talked about how the cube root of a negative is still negative, so that's -1 plus 6, which is 5. So -1 comma 5. 1, 2, 3, 4, 5. That's right here. And remember that, like I said earlier, a cubic function is symmetric, so all you really have to do is just flip it. And so we should get this. Now just to verify, let's use our calculator. By the way, if you're trying to graph a cube root function and you're trying to remember how to do this in your calculator, when you go to graph, you're going to go to Catarl. And then once you go to Catarl, you're going to press the arrow up key. And then once you press that, you'll notice that this pops up. There'll be a tiny little box, and then there'll be a box right here. And in the tiny little box, you can plug in the little 3 for the cube root. Yep. So it's -3, 7, -2, 6, and -1, 5. All right, perfect. That's right. That's what the function looks like. And just to practice, what was the domain and the range of every cube and cube root function? All real numbers, or -infinity to infinity. Both are the same. All right? Okay, now let's go over here to our next one. So it says, write a square root function for the following graphs. All right, let's see. All right, let's see, which one should I do? All right, I'll do 18, I guess. Okay, so in 18. So first, whenever you're doing these graphs, always find out what h and k are. H and k are the center point. So for example, on number 18, the center point is right here, which is 1, 2, 3, 4. So that's going to be -4, comma 1. That's the center point. So if we go ahead and we start graphing this, this will be, they tell us a is 1, so I can kind of just ignore that. So I want to put 1 over b right here, and then this will be x, and that's going to turn into a +4. And then k is, what's k? +1. Okay, so once you plug in h and k, you need to find out what you need to find another point. So I'm going to pick, let's see what else we got here. 1, 2, 3, 4, 5, 6. So that's -6, comma, what is that, 2? So I want to plug that point in. So 2 equals the square root of 1 over b of -6 plus 4. And we get +1 here. Okay, so now all we have to do now is just start solving. So I'm going to subtract 1, and so 2 minus 1 gives us 1. And then this is a square root of 1 over b. -6 plus 4 is going to give us -2. And so how do we get rid of the square root right here? We're going to square both sides. And so we get 1 is equal to, the square and the square root cancel, and you get -2 over b. And if you cross multiply, or just multiply both sides by b, you get b equals negative 2. And so that's our equation. So that's going to be 1 over negative 2 of x plus 4 plus 1. By the way, whenever you run into this situation, whenever there's a cube root, whenever you get the same problem but there's a cube root here, instead of squaring it both sides, you're going to raise it to the power of 3. Okay, so just keep that in mind. All right, so now let's go down here to these last two questions. All right, oh, by the way, so just FYI, just a hint, while you guys are looking at the videos, it might be helpful. I know it's tempting to just try to just copy and just go along, but try to, since it's in a video format, you can pause it, try doing it on your own, and then if you're stuck or you want to check your answers, then you can always go back to the video and hit play, okay? The reason I say that is because I want to do both 19 and 20, but the thing is that it doesn't help you if you're just sitting there just copying what I'm doing. That doesn't help you learn. I'm just going to be honest with you, okay? It doesn't. So try doing it on your own first, and then if you want to check your answers, then come back to the video, and then you can look at the video and see how it's done, okay? Because both 19 and 20, they work just a little bit differently, okay? So I'm going to start with, let's start with 19. So here we go. So like I said, try doing it by yourself. Pause the video if you need to, and then come back and check your answers, okay? So on number 19, it says a equals 1. So that means a is going to be 1, so you can kind of just cancel it out. The reason that is because if you plug in 1, well, 1 times anything is always that other thing, so you can kind of ignore it. All right, let's go ahead and plug in our h and k. All right, so where's our center of this graph? 1, 2, 3, 4, 5. 1, 2, 3. So 5, negative 3. All right, so that's the center of our graph. So this is going to be x minus 5. And there's a minus 3 right here. Okay, so now the next part, remember, like I said, is you need to find out, you need to pick another point. So I'm going to pick this one right here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 comma, what is that, negative 2. So there it is. I'm going to pick 9 comma negative 2. All right. So let's go ahead and let's substitute it in. So this will be negative 2 equals the cube root 1 over b of 9 minus 5 minus 3. Now I'm going to go ahead and move this 3 over by adding. So this will be 1 equals the cube root. 9 minus 5 is going to give us, what is that, 4? So 4 over b. Now remember that, like I said earlier, see this is a cube root, so you can't just square root both sides. You need to cube both sides. And it just so happens that it turns out really nicely this time. But just FYI, this is 1 cubed, so I'm just trying to just give you guys a hint. In the future, if you ever get 2 cubed, okay, that's not 6 and it's not 4. 2 to the power of 3 is 8, because that's 2 times 2 times 2, which is 8, okay? So just FYI, a little knowledge for you guys. All right, so 1 equals 4 over b. Multiply both sides by b, and we get b equals 4. And so what's going to go in my denominator right here in this equation? We're going to get y equals the cube root of 1 over, excuse me, that should be a 4. And so this should be x minus 5 and minus 3. By the way, just a quick question. What is that? A horizontal what? What is this? Since b is equal to 4, what is that? A horizontal what? Stretch or compression? What do you think it is? You said stretch, you're right. Because remember, b is greater than 4. Excuse me, 4 is greater than 1. So because this number is greater than 1, that's a stretch. All right. So now let's go ahead and let's try 20 over here. So in this case, b is equal to 1. So what you're really looking for in this case is you're looking for a. So that kind of makes this equation look a little bit nicer because it just looks like this. And so we can go ahead and just go straight to just plugging in what h and k are. And so where is the center of this graph? And it looks like it's right there, 0, 3. So 0, 3 is the center. So it'll be x minus 0 plus 3. Oh, look, that's nice. That's nice. Because it's 0, I can actually just ignore it altogether. So that's just a, the cube root of x plus 3. All right, so I'm going to find another point. I'm going to use this point right here. Okay, 1, so that's over 1, so that's 1 comma 1 2 3 4 5 6 7, 1 comma 7. So it'll be 7 equals a, the cube root of 1 plus 3. And let's go ahead and let's solve. So we get 4 equals a. Now I'm going to show you this because it may not always happen, and this will help you. Okay, now it just so happens that by accident we got a 1 right here underneath the cube root. Now the cube root of 1 is 1, which makes it nice, and so a equals 4. So that makes it nice, but just FYI for future reference, you may get something else underneath here. In that event, you'll need to cube both sides. Well, actually, you know what? Now that I think about it. Actually, never mind. Disregard. If you plug in known points that are on the graph, you will always get something underneath this cube root that you can take the cube root of. So like you'll get a 1, 8, 27, what else is there, 64. So yeah, it'll always turn out to be something you can take the cube root of. So finally, here's our equation. So we get 4, the cube root of x, and of course we got nothing underneath the square root. So here, or the cube root, excuse me. So 4, the cube root of x plus 3. And there's your equation. And by the way, since a is greater than 1, that's a vertical stretch. All right, and so that's your test review. And yes, I'm aware that I didn't do all of it. Okay. Well, the reason I skipped around some of them is because they're almost identically the same, some of them. All right. So, yeah, so for example, some of the ones that I skipped are almost the same concepts. Okay. All right, so good luck. All right, the good news is I guess this is on a video, so you guys can always come back and check in on this and look at it as many times as you guys like. All right, so good luck. Your test is still going to be Wednesday. All right, make sure that you're turning in your assignments. You look at my board, turn in what it is you guys need to be doing on time. All right, and good luck on your test. All right. If I remember correctly, last time we had a test over this content in this class, people did very, very well. Okay, so good luck to everybody.